on the document, this is the very first problem. It says, and again, this is a cumulative test, so it's going through all 4 modules. Okay, so number 1 says a randomly selected group of individuals were asked how many marbles they believe were contained in a sealed jar. The following frequency distribution summarizes the results. Complete the table by determining the midpoint, relative frequencies, and cumulative frequencies. Now, as far as the printout itself is concerned, it's not very print friendly. So taking a look at the problem itself.
It's supposed to be like a table with
right.
Okay.
So this is what it actually looks like. Yeah. All right. And the print version. But I'm going to actually write it out as you would see it on the computer. So we have the classes, and then we would have the frequency. Right. So that first class is 189 to 198.
180 to 190.
Oh, 180. Okay. To 198. 199 to 217. 218 to 236. 237 to 255. 256 to 274. And then we have our frequency, which are 3, 7, 8, 12, and 4. And we're asked to find the midpoint, the relative frequency, and the cumulative frequency. Okay. Uh-oh. Okay. All right, so this is our frequency distribution, right? Okay, so you'll kind of see it like this on the computer, right? Okay, so we have our classes. There are 1, 2, 3, 4, 5 classes. We have the frequency for those classes, and we have to find the midpoint. So just remember, in order to find the midpoint, we take the lower limit plus the upper limit, and we divide by 2. All right, so the first midpoint would be 180 plus 198. So notice I'm going to hit enter. I want to simplify the top. Divide by 2, and we have a midpoint of 189. Okay. Now I can also do that for the next class, 199. Well, I'll do it all in one step here. I'm going to use a set of parentheses. All right, I'm going to put in 199 plus 217. I'm going to divide that by 2, and I get 208. Now, I could save a little bit of time, and I can actually find the class width, right? And I can just simply keep adding the class width. So what I mean by that is, in order to find the class width, you would either subtract either your upper and lower limits. So if I were to subtract 199 right, which is the lower limit for the second class, minus 180, which is the lower limit for the first class, right? I get 19. I can simply keep adding 19. Okay. So what I mean by that is 189 plus 19, which is the class width. That gives me 208. I can add 19 again. That would give me the next class midpoint, which is 227. I can add 19 again. I get 246. And if I add 19 again, I get 265. Right? So there's one or two ways you can do it. You can either use the formula for each class, or you could use a formula, midpoint formula for the first class, and just simply add the class width. So that's the midpoint. The next column is the relative frequency. So in order to find the relative frequency, you take the class frequency and divide by the total frequency. Right. So that total frequency, I have to add up all of my frequencies. So the total frequency is 3 plus 7 plus 8 plus 12 plus 4, right, which gives us 34. Okay, so that's going to be my divisor. So in order to find the relative frequency for the first class, I'm going to take the frequency for that class, which is 3, divide that by the total frequency of 34. The relative frequency for the next class is 7 over 34. The next is 8 over 34, 12 over 34, and then 4 over 34. Now, I'm kind of leaving these things as fractions, but I believe in the problem, they want you to answer it as a decimal, rounded to 3 places. So just to save time, I'm just putting these things in as fractions. All right. Any questions about that relative frequency? And then the next column is the cumulative frequency. So remember that the cumulative frequency is the frequency of the class plus prior classes. So the cumulative frequency for this first class, since there are no classes prior to it, the cumulative frequency for the first class is 3. The cumulative frequency for the second class is 7, but you must add all of the classes prior, so it's 10. The cumulative frequency for the next class would be 18, right? 8 plus 7 plus 3 is 18. For the next class, we have 30. And then for the last class, 34, right? So those two must match. The cumulative frequency for the last class should always equal to the total frequency. Okay. All right, so the print version isn't too friendly, but this is how you actually see it on the
It's going to have the table
exam. Right. Okay, all right, for the next problem, it says the following data set outlines the scores students on an algebra test had, and they simply want us to fill in the frequency table. They just simply want us to find the frequency. So we're going to put this data into the calculator, and we're basically going to put it in order from smallest to largest, and then we're just going to count the frequencies or count how many numbers fall within these class ranges. All right. So remember, in order to put a data set into your calculator, I'm going to use stat. I want to choose this first option, which is edit. So I'm going to put everything in list 1. So remember to quickly clear a list. You can go to the very top of the list, hit clear, and enter.
Now, if I'm not mistaken, when you said the smallest to the largest, when we put that in the calculator, it will do it for us.
Yeah, it's going to do it for us. We'll put in a function to do it for us. All right, so I'm going to enter those values into this one. All right, so once you have the data into the calculator, you want to return to your home screen, which is second in mode, which is that quit key. And then I'm going to go back into stat, and I want to choose sort A. That's ascending order, so it puts the numbers in order from the smallest to the largest. It didn't go back? Okay. We got to hit second. Then go back in the stat. Sort A. And then you have to tell it which list you want to sort. That's right. And then we want to sort list 1. So list 1 is above the number 1 and it's yellow. So you must hit second and 1. That's right. And then you should see list 1 pop up. And now if you close off that parenthesis, that function with the parenthesis, and hit enter, it doesn't really appear that it done anything, it just says done. But if you go back in the list, go back into stat, and then hit edit, you should see those numbers are now in order from smallest to largest. Okay. So now it's going to be kind of, it'll be easier to pull them out this way, organized versus just in the, a bunch of scattered numbers. So how many numbers are in the range of 40 to 49? Looks like 4, right? 1, 2, 3, 4. So that first class frequency is 4. From 50 to 59, it looks like 1, 2, 3, 4, 5. Looks like 6. All right. From 60 to 69, 1, 2, 3, 4. Looks like 4. 70 through 79. 1, 2, 3, 4. Is it what? 1, 2, 3, 5. 5. So what I'm doing is, since this class is like 80 to 89, I'm going to bring up well, looks like it's only 1, right, for that one. It's only 1 for that one. And then 90 through 99, there are 5, right? 5. Make sure you put, if you go back and check your numbers, that's why you want to double check these, because if you put in something, the number, yeah. It's 5, okay. All right. Or you can just kind of go through them in X amount if you want to. Okay, okay. All right. So the second part says draw a histogram below by drawing a horizontal line segment at the top of each histogram bar. So we're basically going to visualize this graph physically. So what that means is for the class range 40 to 49, the frequency is 4. So if you look here, this is 40 through 50, right? I'm going to go up to 4 and just draw a vertical line, a horizontal line. That's right, horizontal line. From 50 through 59, that's 6. So for the next range, I'm just going to draw a horizontal line at 6. 60 through 69 is 4. So I'm just going to draw a horizontal line at 4. 70 through 79 is 5. So a horizontal line at 5. 80 through 89 is 1. And then 90 through 99 is 5. All right, so that's the histogram that accompanies that frequency distribution. Okay, next we're asked to calculate the following for the given frequency distribution. So here we have a frequency distribution and we want to pull out the population mean and the population standard deviation. So now in order to find the population mean and the population standard deviation for this frequency distribution, we have to add another column, which is the midpoint. Okay, and then we're going to go in our calculator and we're going to put in the midpoint as list 1. We're going to put in the frequency as list 2, and then we're going to use that one variable statistic. Okay. All right, so here again, we got to find the midpoint. So remember the formula for the midpoint was the lower limit plus the upper limit divided by 2. So to find the midpoint for the first class, I'm going to go back to my home screen, which is second and mode, which is the quit key. 70 plus 73 divided by 2 gives us 71.5. So that's the midpoint for the first class. And just to save a little bit of time, I'm going to find the class width and just keep adding that class width. Okay. So remember the class width, you can subtract the lower limits from consecutive classes or the upper limits for consecutive classes. So I'm going to just use the lower limit. So the lower limit for my second class is 74 minus the lower limit for my first class is 70. So that gives us a class width of 4. So now I can just simply add the class width to my midpoint. So 71.5 plus 4 should give us 75.5. Right. If I add 4 again, we get 79.5. Add 4 again, we get 83.5. Add 4 again, we get 87.5. And if you add 4 again, you get 91.5. Right. So we have found the midpoint. So now in order to calculate the statistics, I'm going to go back into stat. Okay, and we're going to edit the list. So I'm going to choose that first option. And I'm going to clear out list 1. So I'm going to go to the very top of the list. I'm going to hit clear and enter. All right. So once you put everything in your calculator, I would just double check it. Take a second to double check it. I'm going to go back to the home screen. So that's second in mode, which is quit. Okay, I'm going to go into stat. I'm going to scroll over to calculate, and we want to use a one variable statistics. Right. So now my calculator looks a little bit, if you have a TI-84, it looks a little bit different. Since I'm using 2 columns, I have to tell the calculator I'm using 2 columns. So I'm going to put in list 1, comma, list 2. But if you have a TI-84, I believe it says what, X list and then frequency. Okay, so if you have a TI-84, so list was first, right? So for list, you're going to put L1 and then frequency list, you're going to put in L2. That's only if you have a TI-84 or 84 plus. All right, and then once you hit the one variable statistics, you see something that looks similar to this. Okay. All right. So just make sure that when you're dealing with those lists that you clear them all out first. Okay. So now we want to pull out the population mean. So now the population mean and the sample mean are exactly the same. So that's going to be X bar, which is 79.44, right? For the population standard deviation, there's 2. This S sub X is the sample standard deviation. This sigma sub X is the population standard deviation. So just keep that in mind on what they're asking you. So here we want the population standard deviation, and that should be 6.1, right? Now if they ask for the sample mean, okay, the sample mean would still be 79.44. But if they ask for the sample standard deviation, then we would get 6.15. Right, so since they're asking for the population, we're going to use that sigma sub X, which is 6.1. All right, any questions so far? All right, so for problem number 4, I'm going to kind of slight problem number 4. There is a video on the home page. I'm actually going to move it up. Which was this one? Because this problem popped up a few times. I think it was on another test. And on this video, I got that exact same problem. All right, for number 5, it says a coin is tossed twice. Let E be the event the first toss shows a heads, and F is the event that the second toss shows a head. Answer the following questions using fractions of decimal rounded to 3 decimal places. The first question says, are the events independent? Yes or no? Well, if you flip a coin one time and then flip a coin another time, do those 2 coin flips have anything to do with each other? No, so they would be independent. Right. B says find a probability showing heads on both tosses. So we're going to use that fundamental principle of counting. So I'm going to just map out two outcomes. This first outcome is the probability of a head, and that second outcome is the probability of a head. So now if you have a coin, what would be the probability of flipping a head? Right? Well, if we use that fraction, right, the part over the whole, there are two outcomes, right? Either head or tail. That's the denominator. The numerator is how many heads are possible? One. So the probability is a half. What's the probability of a head for the second toss? Also 1/2, right? Because the two events are independent. So now I'm just going to multiply both. So when you multiply fractions, you multiply the numerators and multiply the denominators. So 1 times 1 is 1, 2 times 2 is 4. And if you change 1/4 to a decimal, well, it says you can use a fraction or a decimal. So you can either put in 1/4 or 0.25. So the independent events and the probability that you flip it twice and both are heads are 25%, which is a fairly good chance that could happen. All right, number 6 is the license plate example. So it says a state license plate consists of 2 letters followed by 3 digits. How many possible license plates can be issued using this condition? Okay. So now, keep in mind, this is not asking for like a probability. It's asking for how many possible outcomes. So I'm going to use the fundamental principle of counting. I'm going to map out 5 outcomes. So 1, 2, 3, 4, 5. Right. So the first 2 are letters. So how many letters are there to choose from? Right? There's 26 letters in the alphabet. So I can choose 26. Well, I have a choice of 26 letters for this first letter, right? For my second letter, I have a choice of how many letters? Still 26, right? Followed by 3 digits. Right? So remember, the digits are 0 through 9, so that gives me 10 digits altogether, right? So I have 10 choices for my first digit. I have 10 choices for the next, and then 10 choices for that last digit. So now we're just going to multiply all these things together. So let's clear this out. 26 times 26 times 10 times 10 times 10. Right, it's 676,000 different possible license plates, okay, given these conditions. All right. Okay. Any questions about that one? All right, now the next, I believe, 4 questions, or the next 3 questions, they deal with combinations and permutations. So just remember that for permutations, this is just a hint, the order matters. Examples are plays and runners replacement of first, second, or third. These are two main examples because in plays, it matters who plays what role, right? For runners, when you're talking about placing first, second, and third, or gold, bronze, and silver, the order matters because you don't want to give the gold medal to the person that walked across the finish line last, right? So order matters. And those are some examples, okay? So for number 7, it says if you have 6 volunteers for a play that has 3 characters in it, how many ways can you cast a play? So is that an example of a permutation or a combination? Well, since we're talking about a play, that should be a permutation. All right. So remember, for a permutation, we have N permutate R, where N is the total and R is N is the total to choose from. R is the total chosen. So we're going to set this up as a permutation. So first off, how many people do we have to choose from? There's 6 people to choose from, right? So that's going to be 6 permutate. And then how many people are we actually choosing from the 6? 3. So that's 6 permutate 3. And that's what I want to put into my calculator. All right. So I'm going to put in the total number to choose from first, which is 6. And then I'm going to go into math. I want to scroll over to probability. That PRB is just short for probability. And I want to choose the second function, which is permutation. And then we're choosing 3. So I have N permutate 3. And that gives us a total of 120 ways we can cast a play. So notice that this is not asking for a probability. It's asking for how many ways can we choose something. And in this particular case, what we choose matters, okay, because we're dealing with a play. So that is number 7. All right, number 8 says, well, any questions about 7? All right, so anytime you see the word play or casting a play, that should always be a permutation. 8 says a basketball team contains 17 players. If 5 people can be on the court at one time, and it does not matter which position anyone plays. So that means that the order does not matter. So that's a what? Combination. How many different groups can be selected to be on the court? So here we're going to use a combination that's N choose R. So again, N is the total number, in this case, of players to choose, which is what? 17. And out of those 17, how many are we going to choose to play on the team? 5. Okay, so here we have 17 combination 5. So I'm going to put in 17, which is that total number to choose from. I'm going to hit math. I'm going to scroll over to probability. Okay, math, scroll over to probability. And you want to choose combination 3. And then once you hit enter, Then you want to put in a number that you're choosing, which is 5. So here we have 6,188 different groups that are possible. All right. Any questions about number 8? So the one with the characters in it was a permutation, and then the one with the basketball players is a combination. Okay. All right, number 9. It says you're buying a new car. There are 5 body styles, 3 colors, and 6 models. How many different choices of car are there? So now this is similar to the license plate example, right? So it says how many different choices are possible. I'm going to map out 3 outcomes. One outcome is for the body style. The next outcome is for the color. And the next outcome is for the model, right? So out of the body styles, how many choices are there? 5. For colors, how many choices? 3. And for models, 6, right? So if you multiply all those things together, 5 times 3 times 6, we have 90 different possible cars to choose from.
Okay, so this one.
So yeah, this one now. No.
Okay, I got it. So
Okay.
3
Yeah.
areas that we're looking for with the body style.
That's right. That first outcome was body style. The next outcome was color, and then that last outcome was model. All right, number 10. It says a deli offers 14 toppings. How many different choices of 2 toppings are there? So now notice when they give you like 2 numbers, this would either be a combination or a permutation. So now does combination, right? So we're going to put this in as 14 combination 2, right? So that's 14. And then I'm going into math over the probability. Combination 2 is 91. All right, so 10 was a combination. The order of the toppings don't matter. All right, number 11 says 10 sprinters have made it to the Olympic finals in a 100-meter race. In how many different ways can gold, silver, and bronze medal be awarded? Permutation. Because you don't want the person walking across the finish line getting the gold medal. All right, so permutation. So how many, what's the total number of sprinters? 10. Permutate, and then there's only 3 to choose from, right? Gold, silver, and bronze. So there's 3. So 10 permutate 3 is 720. All right, so we have 720. All right, so any questions about those? All right, number 12, it says, suppose you draw a card from a standard deck, find the probability of selecting a queen or an odd value card. Round the 3, answer as a fraction around the 3 decimal places. So remember we talked about this thing or, right? And there were like 2 formulas. There was an addition formula which says the probability of A plus probability of B minus the probability of A times B. It's like the only way we would use that formula, and I believe the example we were using was pencils. If you have blue pencils in a bag and yellow pencils in a bag only, and you were actually finding a probability, you would just simply add them together, right? But let's say if you had blue and orange pencils in the bag, you'd have to account for that. Since in this problem, we have the probability of a queen or an odd value card. So that means the queen is not an odd number card. So we don't have to use that addition rule. We're simply going to find the number of queens in the deck of cards. We're going to find the number of odd value cards in the deck of cards, and then we're going to just divide by the total number of cards in the deck, right, which is 52. Okay, so I'm just going to bring up the card deck again, because everyone's not familiar with cards. So there's 52 cards in the deck, right? There's 4 suits: spades, hearts, clubs. I play cards. We call them puppy toads or whatever. Okay, and then you got diamonds. There's 52 cards. How many queens are there? There are 4 queens. How many odd cards are there? Well, remember the odd cards are 3, but you got 4 threes.
Oh, so the 1 wouldn't count? Oh, it ain't no 1.
It's not a 1.
I'm thinking about it.
That's right. Okay. 7 and 9. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and then 4 8s is 17, 18, 19, 20. Right? Because we want the number of odd cards or queens. So that's 20 cards altogether to choose from, right? So we're going to take 20 and divide that by the total number of cards in the deck, which is 52. Let me just kind of write this out. So we had 4 over 52, because there were 4 queens, plus 16 over 52, because there were 16 odd cards, right? When you add fractions, you keep your denominator, you keep your common denominator, combine your numerator, so 4 plus 16 is 20. And if we divide 20 and 52, we get 0.385. So 4 over 52, that's the probability of drawing a queen. 16 over 52 is the probability of pulling an odd card. So if we add those 2 probabilities together, right, we get 20 over 52, which is 0.385. So in my opinion, this number 12, this was about the most involved problem. Because you may be tempted to multiply and you might be tempted to do some other things, but find the probability of both and just add them together. All right, now 13 deals with the binomial experiment. Okay, so remember with the binomial, we had the binomial PDF, which determined the exact number of, well, it gives you the probability for an exact value. And then we had the CDF. And the CDF of the binomial, it gives you the probabilities from that number and all of the numbers before it added together. So here's number 13. Well, just to review that binomial stuff. So you have binomial. Okay, where is my eraser? Binomial PDF. And you had to give it 3 parameters, right? N, P, and X, where N was the okay, what was N? I'm having a brain cramp. N was the total number of trials. P is the probability. And X was the number of successes. All right, that was for the PDF. Those 3 parameters are also for the CDF, but the CDF gives you the probabilities from that number and all of the numbers before it added together. Okay. So it says, according to a recent survey, 80% of students say they don't get enough sleep. Assume the survey meets the conditions of a binomial experiment. So remember the conditions. There's a fixed number of trials. Each trial is independent. There's only 2 outcomes, right? In a random survey of 30 students, find the probability that exactly 7 will say that they don't get enough sleep. So since we're finding an exact probability, so I'm going to write this out as the probability that X, and X would be the number of students that don't get enough sleep, is equal to 27. Right? So this is going to equal to a binomial PDF. What is N? Well, N is going to be the total number of students or the fixed number of trials. So in this case, they surveyed 30 students, right? So my first parameter, N, is going to be 30. What is the probability of success? 80%. But we got to change that 80% to a decimal, right? So that's 0.8. And then what's the number of successes? Should be 27, right? And this is what we want to put into the calculator. So remember that the binomial PDF is within distribution, so you have to hit second and variables, that vars, which is short for variables. I'm going to scroll down to binomial PDF. Okay, you want to separate out these parameters with a comma, so it's 30, 0.8, 27. And we have 0.079, right, rounded to 3 decimal places. 0.079. All right, everybody okay with that one? All right, the next question says, in a random survey of 30 students, find a probability that more than 27 of them say that they don't get enough sleep. So remember that I'm going to just write this out in inequality form. So that's the probability that X is greater than 27. So remember, in the CDF, it gives you that number and below. So I'm going to kind of do it like this. P of 0 plus P of 1 plus ... plus. Okay, yeah, there's only, yeah. Plus dot P of 30. So now if I want more than 27, am I actually going to include 27? No, right? So I want 28, 29, and 30, right? So I'm going to use that 1 minus. So the probability that x is greater than 27, that's going to equal to 1 minus the binomial CDF for 30, 0.8, 27. My inequality is x is greater than 27. So that means I want 28, 29, and 30. So I can use that binomial CDF. So since that binomial CDF goes to the left, I can actually find the probabilities from 0 through 27 and basically subtract that from 1. So if I put that into the calculator, this is 1 minus the binomial CDF for 30, 0.8, 27, and we get 0.442. All right, so that should be 0.442. Okay, yeah, 0.44. That's right. 2 decimal places. Now, here's another thing you can do. You can actually use a binomial PDF, which means you can find the probability of 28, the probability of 29, the probability of 30, and just add them together. If you chose to do that. Okay. All right, any questions about number 13? All right, here is number 14. It is still dealing with the binomial distribution. It says a local county has an unemployment rate of 4.1%. A random sample of 15 employees are picked at random from the county and asked if they are employed. The distribution is binomial. Round your answers to 4 decimal places. All right, so A says find a probability that exactly 5 are unemployed. All right, so since this is an exact probability, we're going to use the PDF, right? So the probability that x is equal to 5, that is the binomial PDF, where n, that's the number of trials, is going to be 15, because there were 15 people picked. The next parameter is P. So P is the probability of success. So remember now it's 0.41%. So when you change that percent to a decimal, you drop the decimal and you drop the percent symbol and you move that decimal 2 places to the left. So you should get 0.041. 0.041. And the number of successes is 5. So now once you put that in, you're going to get something that's probably going to look weird. So that's binomial PDF 15, comma 0.041, comma 5. So mine says 2.289, and then it's e to the negative 4. So let me explain that e to the negative 4. That is actually 2.289 e to the negative 4. That's actually 10 to the negative 4th power, which means that you have to move that decimal 4 places to the left. Because I did these in the office, and this e popped up. So here's what that looks like. If I take 2.289, and since this exponent is negative, I move the decimal once, twice, 3 times, and 4 times. So I'm going to add filler zeros. So I get 0.000229.
So what do we put in the calculator to tell us to do only 4 decimal places?
Okay, this one says 4. The answer here would be 0.0002. But I looked on the answer key and they just have 0. If you look on the answer key, there's 2 of them on here I had a question about. This was one of them.
What is 0?
They put 0. Now, if you round to 3 decimal places, that would give us 0. But now it says 4.
Right,
So it'd be 2. All right. I'm going to put a little star by that one. That was one that popped up funny.
I think you should just go ahead and give it
Okay. Right.
If you're wrong.
All right. So I know it would probably give you that if you put that in, but on the answer key they just put 0.
But if it shows a negative exponent, then we just...
Now you move that decimal to the left. That's right. All right. Okay. So now B says find the probability that there are fewer than 2 in the sample. So that's going to be the probability that X is less than 2, right? So in the calculator, you want the binomial CDF for 15, 0.041, 1. Now, if this said it was fewer than, if it was 2 or fewer, then you would put in a 2 for your X value, right? But since you only want fewer than 2, you don't include the number 2 in this.
Subtract, right?
No, you don't subtract because the CDF, it gives you everything to the left or everything lower than the number you're dealing with. Okay. All right. So once you put that into the calculator, that came out right. You should get 0.876. So just to put that in, binomial CDF 15, 0.041, 1, 0. It looks like even though it says 4 decimal places in the question, I'm looking at the answer sheet and it's only rounding in the 3 decimal places. Yeah. So that's probably.
They don't do 4 decimal places.
Yeah. I'm believing that's what's going on because
I think somebody forgot to put 3 decimal places.
I believe that should be a
That's how
3.
they got the 0.
Yeah, that's how they got 0 for that first one.
3 decimal places.
All right, now C says find the probability that there are more than 2 in the sample. So keep in mind it's the binomial CDF gives us from that number below. Whenever it asks you for more than, you got to use that 1 minus. So in order to write this out as an inequality, we want the probability that x is greater than 2. So that's going to be 1 minus the binomial CDF for 15, 0.041, 2. So if you put that into the calculator, you should get 0.022. Now the last one says find the probability that there are at most 2 people in the sample. So now at most 2 means that there can be 0 people, 1 person, and it can be 2 people, right? Because it didn't say 2 or fewer, it says at most 2. That means you can't have anything higher than 2, but you can have 2, right? Right. So I'm going to write this out as the probability that x is less than or equal to 2, right? Because you can have at most 2. You can't have more than 2, but you can have at most 2. So here we can use that binomial CDF. And this is 15, 0.041, 2. So if we put that into the calculator, we get 0.978.
So if it says 4 spaces, are we going to do 4 or are we going to do 3?
If it says 4, I would do 4.
Okay.
Because it has like a margin of error in it for some of these questions.
So this thing says 4 spaces.
All right. So there are about, about 6 questions dealing with that binomial distribution.
Round to 4 decimal places.
Right, but on the answer key, they're only rounding to 3 decimal places. So, all right, number 15, 16, and 17, they're dealing with the normal distribution. Okay. All right, so 15 says find the area of the shaded region under the standard normal distribution to the right of the given z-score. Round to 3 decimal places. So for this one, we're going to use the normal CDF function. So since this is normal, this is a normal distribution. The normal CDF function operates totally different than the binomial CDF, right? The binomial CDF only gives you the probabilities for the number and below. Whereas the normal CDF, it'll give us exactly what we want, right? So just remember in this bell-shaped curve, this normal distribution, to the extreme left you have negative infinity, and to the extreme right you have positive infinity. Right? So those infinity symbols mean that negative infinity means that the numbers keep getting smaller and smaller and smaller and they never stop. Positive infinity means that the numbers get bigger and bigger and bigger and never stop, right? So this curve never actually touches this axis. So it kind of goes out forever. In order to find this area for the normal distribution, I'm going to go into the normal CDF. So here are the functions. You have to put in the lower limit, the upper limit, the mean, and the standard deviation, right? So if we look at our shaded area, the lower limit is the lower limit is positive 1.25. I'm going to put in 1.25 because that's my lower limit of the shaded area, comma. The upper limit for the shaded area is infinity. So we're going to put infinity in as e to the 99th power. That's how it's represented in the calculator. So e is above the comma, and it's a yellow function, so I'm going to hit second and the comma, and it gives me e. And I'm going to raise that to the 99th power, comma. Since this is a standard normal curve, the mean is 0 and the standard deviation is 1. So I'm going to put in 0, 1. And then we have our area, which is 0.106. So 1.25 e to the 99, 0, 1 is 0.106. All right, so any questions about number 15? All right, so we just put in that lower limit.
Lower limit is already,
Well, they give this lower limit is the lower part of that shaded area. Infinity. So even though you see like 4, that keeps on going. Yeah, it keeps on going, so you want to put in infinity. All right. So we take a look at number 6. It says the graph of a normal. Okay.
So where it has the P, where it has the Z is greater than 1.5, that's how I know that my upper limit is
That's right.
infinity.
That's right. That's
Okay.
right. That's right.
That's what I was trying to figure out. Okay.
All right, now number 16, it says the graph of the normally distributed random variable is given. Use the graph to, that should be answer the questions below. It says, I did. Okay, and that was Bush, right? Jones, okay. All right. All right, so we want to know the mean, the standard deviation, what percentages fall between 21 and 27, and which has a z-score of -2. So remember that the mean is located directly in the center. So the mean here is going to be 21. Now it seems to be offset a little bit, But if you look at the graph closely, all of those numbers are offset. So that little tick mark is kind of to the left of the actual number, right? So if you look at 3, notice that 3 isn't directly under that tick mark. It's slightly to the left. So the mean is going to be 21. What's the standard deviation? Well, the standard deviation is going to be the distance between these tick marks. So if you take 9 and 3, that distance is 6. Or if you take 15 and 9, that distance is 6. So that gives us the standard deviation, which is 6.
This is the one that always stopped me when I do this percentage. When
The percentage.
When it asks you what it falls, that's the one I can't ever get where I get the percentage.
Okay. So I'm going to bring up
That's the part.
this empirical rule. Let me see if I can find that really quick. All right, so here's that empirical rule, and I'm trying to pull up our internet is running slow. Okay, so while this is loading up, that empirical rule is the 68, 95, 99.7 rule, and it gives us the okay, it's coming up now. It gives us the percentages based on where our numbers lie. Okay, so here we go right here. Let's bring it up. Okay, this is moving slower down. I guess I can bring it up from here. Okay, so this is the empirical rule right here. So for the standard normal, just the mean is 0 and the standard deviation is 1, right? So this one gives us, this is kind of what I'm looking for. So it says that 68% of the data is within 1 standard deviation. If you look at this second example, 34 plus 34 is the 68%, right? If we line that up with ours, and we want to know what's the percentage of value between 21 and 27, well, this is 21, and then this would be 27. So it would be 34%. All right, so if I were to just put all my numbers in this, okay, I'm going to slide that over. So this would be 3. This would be 9. 15 would be here. 21 would be here. 27 would be here. So the area between 21 and 27 would be the 34%. So here we should have 34%.
So how do I, so if it's not showing me the percent, so I just have to know where the percentages are.
Right.
Oh.
There was a,
We
let's
got
see.
it in our,
Yeah, we do. It was in the lecture notes. Okay.
Okay.
So you want to definitely use that. Okay.
Okay.
Now the next problem says, what is, let me find out where I am again. which value has a z-score of -2. So if you look at the z-scores, and I'm going to bring up this empirical rule again, the z-scores, they kind of range between -3 and +3. So if we kind of line this up with our problems, -3 would be 3, -2 would be 9, -1 is 15, and then 0 is 21. So if we're asked to find which value has a z-score of -2, that would be 9. Right, because our z-scores are -3, -2. Oops. Let me just blow this up. This would be -3, -2, -1, 0, 1, 2, and 3. So -9 would be the z-score of, 9 would be the z-score of -2. So that would be 9. All right, so that's number 16. So you will need that empirical rule. Okay. And it's in the lecture notes. All right, number 17, it says, in the country of the United States of Heightlandia, the height measurement of 10-year-old children are approximately normally distributed with a mean of 53 and a standard deviation of 3.5. So I just kind of mapped that out. The mean is 53, and the standard deviation is 3.5, right? A says, what's the probability? So remember that probability and area are the same word. What is the probability or area that a randomly selected child has a height less than 51.85? So if I kind of map that out on my normal curve, okay, I'm going to guesstimate 51.85 to be about here. And we want the area below, okay, the area less, or the height less than 51.85. Right, so just remember we have negative infinity on the leftmost and then positive infinity on the rightmost. So in order to find this area, I'm going to use the normal CDF. I'm going to put in the lower limit, which is -e to the 99. I'm going to put in the upper limit, which is 51.85. I'm going to put in the mean, which is 53, and the standard deviation of 3.5. So this would give us the area for that probability. So I'm going to recall that normal CDF. So I'm going to go back into distribution. Okay, normal CDF, -e to the 99, comma 51.85. Those are my lower and upper limits.
I put in my -e because
you want to make sure you use that negative
that one to the bottom
and not the minus. That's right. That's right. That's right.
-e.
Right, and you should get 0.371. And for B, it says, what is the probability? So again, area is probability that a randomly chosen child has a height more than 62.4. So if I were to map that out, right, 53 is the mean. Standard deviation is 3.5. 62.4, I'm going to guesstimate that about here. So we're going to use that normal CDF. We have to put in the lower limit, which is 62.4. We put in the upper limit, which is infinity, which we express as e to the 99. The mean is 53. And the standard deviation is 3.5. So 62.4 comma e to the 99. 0.004, right? 0.004. All right, and then for the last problem, it deals with a confidence interval, a population confidence interval. And it reads, if n is equal to 40 and p hat is equal to 0.05, construct a 90% confidence interval. Now, since we want the confidence interval of a proportion, we're going to use the one proportion z interval. So I'm going to go into stat. I'm going to scroll over to test. And we want the one prop, which is short for proportion, z interval. Okay, so now it asks us for x, it asks us for n, and it asks us for the C level, the confidence level. So now we know x is 140, right? I mean, we know that n is 140. So remember, like, n is the number of trials. But they don't give us x in this problem. What we have to do is we got to set up an algebraic equation to find x. So this is how we do that. There's a formula to find p hat, right? So I'm going to use that formula. P hat, that's equal to x divided by n. I'm not giving a value for x, but I'm giving a value for p hat. So p hat is 0.05 and n is equal to 140. So I'm going to substitute in those values and I'm going to solve it for x. So p hat is 0.05. That's equal to x, which we don't know, divided by n, which is 140. In order to solve for x, I'm going to multiply both sides by 140. So if I multiply the left-hand side by 140. If I multiply the right-hand side by 140, right, the 140s cancel on the right-hand side. So remember from algebra, even though this is not an algebra class, whatever you do to one side, you got to do the same thing to the other side to maintain equality. So if you multiply both sides by 140, notice that the 140 on the right-hand side cancels, and that leaves us with x. And if we multiply 140 times 0.005, that's going to give us, 140 times 0.05, that gives us 7. Right, so if we were to take 7 and divide that by 140, that should give us the 0.05. But for our calculator, we need x and n. So I know n, and we've just found x. So we're going to put those into the calculator. So I'm going to go back into that one proportion z interval. All right, so I'm going to hit stat, scroll over to test. All right, one proportion z interval. Okay, I'm going to put in x for 7. N is 140. The confidence level is 90%, which is 0.9. And then if we calculate, we get the confidence interval, which is 0.
I'm using one.
Prop z interval.